Linear algebra, the mathematical concept of linear independence. This lecture is going to be about the intuition behind linear independence. And so before we get into the maths, which we'll do in the next lecture, we're going to talk about the intuition of linear independence first. To do this, we're going to consider a slightly bizarre analogy. Suppose, for instance, that you are standing in a field. You have with you a bag of instructions or directions that tell you where you're allowed to walk. E.g., one instruction might be, walk forward 3 steps. Or another might be, walk sideways 2 steps. If we take these instructions as an example, walk forward 3 steps and walk sideways 2 steps, it's quite easy to imagine that we will be able to walk everywhere in the field simply by first adding the directions of all the instructions together, in other words, performing vector addition, and secondly, being allowed to do the same instruction any number of times, i.e. scalar multiplication, even a negative number of times. Linear independence is the property of a set of instructions that, if we want, rather bizarrely, to stay exactly where we are, the only way we can do that is by not following any of the instructions at all. Or in other words, to follow each instruction 0 times. Even if that doesn't quite resonate yet, let's look at the converse, linear dependence. Linear dependence says the opposite. It says that I can follow some instructions and actually end up where I started. I.e., I can follow some directions and go nowhere. Now, if we think about this carefully, we realize that linear dependence and independence is a property of a set of vectors. To give you some more intuition before we look at the maths, let's go through in more depth what we might mean by linear independence. So suppose we're in our field again, and our objective, just as before, is to go nowhere. You have 2 instructions with you, and for example, one might be walk north 1 step. The other might be walk east 1 step. Then we can just see diagrammatically that the only way to go nowhere is to do 0 of the first vector and 0 of the second vector. So going north, going east, this is our man in the field. If we want to go nowhere, the only way we can do that is by not going north at all and not going east at all. i.e. we take 0 of the first vector, or do 0 of the first instruction, and 0 of the second instruction. Let's compare that with linear dependence. So now all of a sudden we're in our field again, but an objective is still to go nowhere. But let's suppose this time we have 3 instructions with us. The first is to walk forward 1 step to the north. The second is to walk to the east 1 step. And the third is to walk diagonally up to the northeast 1 step. Now all of a sudden we can go nowhere, but still actually follow at least some of the instructions. How? Well, let's see it in a diagram. So now we can go nowhere by following none of the instructions. Just like we could before, but we can also go nowhere by actually following some of the instructions. For example, you could walk north 4 steps. You could walk east 3 steps. And walk diagonally northeast minus 5 steps. So we're going diagonally northeast. Now I know that's not exactly northeast, but bear with me. Minus 5 steps northeast. And what's the result? We have ended where we started, which in this situation is actually a result, something to be very excited about. Now let's think carefully about what we've done here. The first thing we did is we did 4 of the first instruction, 4 steps north, plus 3 steps east, minus 5 steps northeast, and the result is 0. We're exactly in the same place as we were before. So intuitively, we now have this idea that with a set of linear independent vectors, the only way we can go nowhere is by, to use our metaphor, to not follow any of the instructions. For linearly dependent vectors, we can actually go nowhere even if we follow some of the vectors or instructions. Why does this work? Because in some sense the vectors cancel themselves out. Now we have some sense of the intuition of linear independence and dependence. Let's think about the maths behind it, and we'll talk about that in our next lecture.